Myself, Hema Balan. Our project topic is performance optimization of supersonic airfoil using co-flow jet. This is the list of content. Our abstract is we are going to implement the CFJ method in the existing airfoil. Here, CFJ is used as a secondary flow control method to improve aerodynamic performance and stall characteristics. For simulation, we had used ANSYS Fluent software for the analysis purpose to find the aerodynamic performance and stall characteristics. Due to the high pressure in the lower surface of the airfoil, we have installed suction port near to the leading edge and the injection port near to the tailing edge. The result indicate that CFJ can effectively improve supersonic airfoil performance by increase in lift and drag ratio, and drag is minimized. The introductions. In airfoil, there will be a primary flow pattern. We creating the secondary flow pattern using co-flow technique. By creating the secondary flow, the flow separation is delayed and enhancing aerodynamic efficiency. During supersonic speed, the shock wave created and due to boundary layer is separated and wave drag formed. We can able to handle the situation using this technique. Fuel consumption also will be reduced. This is the baseline airfoil, and there is a co-flow jet airfoil. In co-flow jet, there is a injection and suction port. With the help of pump, this technique will happen. The dimension of an airfoil, we take NACA 0008 airfoil. In leading this section port in to the leading edge from 160 mm, that is 16 percentage. The injection port for there is 70 percentage from the cord length. The both suction and injection slot size is 20 mm. The location of suction injection slot. These locations are taken from the base paper, the low boom and low drag design method for supersonic aircraft and its applications on airfoil. The literature review. We are take six literature review. The fourth one, the low boom and the low drag design method for supersonic aircraft and this application on airfoil. This is our base paper. In the document, focus on challenge of reducing sonic boom in supersonic flight, a key obstacle to commercial viability. The proposed concept were tested using Diamond and NACA 0008 airfoils, demonstrating its effectiveness in lowering both sonic boom intensity and wave drag. The research gap. There is a limited analysis of different slot position in a co-flow jet for supersonic studies. There is a lack of optimization for aerodynamic performance at supersonic speeds. Lack of comparative studies at supersonic speed. Next one is objective. To improve the stall characteristics by using co-flow jet method, to reduce drag and improve lift to drag ratio, to convert strong shock wave to weak shock wave formation by using the different slot position of co-flow jet method, to validate the performance through analysis fluent simulations. This is a research methodology. First one is they want to study on supersonic airfoil, then literature review, then refine the problem and objective, then do the geometry and CFJ configuration of baseline and the CFJ airfoil in the ANSYS fluent software, testing and analysis. Next, simulation setup, and we want to run the simulations, and um, uh, there is one kind of answer, that is a parametric study, and the result and discussion and conclusion. This is a design of baseline airfoil for NACA 0008 in CATIA. XY coordinate points are the data set for the NACA 0008. And then we want to do meshing in the ANSYS Fluent software. This is a boundary conditions for the CFJ airfoil. For inlet, we want to pressure Fairfield. In that inlet, we want to add the Mach number. And for outlet, there is a pressure outlet. For injection, there is a mass flow inlet. The mass flow rate is 20 kg per second. The pressure is a constant 010325 Pascal. For suction, there is a mass flow outlet. For that, the mass flow rate is 20 kg per second. This is a pressure contour for Mach 1.5 and the 8 angle of attack and the velocity contour. This is a determination of CL by CD value so compared to the baseline. In this, the CL is 1.06% increase and drag is 3.57% decreased in 8 angle of attack. Next, at Mach number 1.7, this is a pressure contour and this is a velocity contour for 10 angle of attack. This is a determination of CL by CD. The CL is 0.35% increased and the drag is 1.25% decreased at a 10 degree of angle of attack. The next one is for Mach number 2. This is a pressure contour and this is a velocity contour for angle of attack 8. The determination of CL by CD. The CL is 0.45% increase and drag is a 1.2% decrease at the 8 angle of attack. This is a Mach number 2.5. For 2.5, at 0 angle of attack, determination of CL by CD, 48.43% increase and drag is 8.12% decrease at 0 angle of attack. Um, and we change the location injection and section slot locations for Mach to 0 degree angle of attack velocity contour. This is a pressure contour and this is a velocity contour determination of CLBCD. And this CL value is increased by 59.74% is increased and drag is 13.95% decreased at 0 angle of attack. um, Result and discussion. In this study, numerical computation we carried out for free stream Mach numbers in 1.5, 1.7 to 2.5. The aerofoil cone length is 1 meter. The boundary condition is set as mass flow rate outlet for suction, mass flow inlet for injection. Section at a 16%, injection at a 70% of your cone length. The lift value is increased at a Mach number 1.5 is 1.06 for 1.7, 0.35 for 2, 0.45 for 1.2.5 for 48.43%. The highest value is for injection and suction location 59.74% lift is increased. For drag value, for suction and injection and suction location 13.95% is decreased. This is the highest value. In the conclusion, the application of a co-flow jet at 16% suction and 70% injection of a cone length has shown significant aerodynamic improvements, especially at higher Mach numbers. The CL by CD ratio improved consistently across all test cases, with a particularly notable performance at Mach 2 for injection and suction location, where lift increased by over 59.74%, drag decreased by 13.95%. The result validated the effectiveness of chosen suction injection location. The CAD aerofoil demonstrated better aerodynamic efficiency than the baseline aerofoil, indicating its potential in supersonic application. This is a reference. Thank you.